We should be having a look at kinematic solutions, which is motion in a straight line and motion in the plane for your CET test 3. Here we go. The very first question is they have given the x coordinate and time relationship. They're asking average speed over the interval t equal to 0 to t equal to 4. Well, here's the thing. If you see that you look at the relation, this resembles S is equal to ut plus half at square. Well, there are two possibilities. One for acceleration positive and the other for acceleration negative. If acceleration is positive, then average speed shall always be the S, what is ut plus half at square, that thing divided by time take. As simple as that. But whenever acceleration is negative, see here acceleration is negative, ut plus half at square, there is a minus sign, so acceleration is negative. Here, average speed has a certain a kind of a trick to it. Okay, the trick is v square plus u square by 2at. V square plus u square by 280, where v is the velocity of the object at t equal to 4, u is its initial velocity, a is its acceleration, and t value is anyway given as 4, right? So you can use this direct formula. This is for cases where acceleration is negative. All we need now is to find out u and a. Coefficient of t is u, so u equal to 7, and half times acceleration is the coefficient of t square, which is minus 3, and a should be equal to minus 6. We don't consider the sign of acceleration over here because speed is obviously always positive. So in this thing, it is only magnitude of acceleration. We'll now go with v equal to u plus at and find the speed at the end of 4 seconds. U is 7, a is minus 6, and t is 4. So that would give me around minus 17 meter per second. So v is 17, 17 square is 289, and u is 7, 7 square is 49, and acceleration is already given. Magnitude I will take 6, and the value of t is 4. So when I simplify this entire fraction, I get somewhere around 7.04, approximately it should be 7 meter per second. So this is how it goes. Whenever you have S equal to ut plus rpt square, either if it is positive acceleration, fantastic. You simply take displacement by time, you'll get the average speed. But if it is not positive acceleration, if it is negative, then you can use v square plus u square by 280, put the value of v, u and a you can figure out from this equation, and that's all. That's average speed is 7.24, around 7. Now question number 2. In question number 2, they're asking what is the displacement of the particle in the last 1 second. So here is where I will assume t itself, this value of t itself as 1 second. So all I need to do is find the displacement at t equal to 1 second. Because the last 1 second would obviously mean this 1 second. If t itself is for 1 second, that would mean last 1 second is nothing but the t value. So what is the displacement at t equal to 1 second? Ut plus half at square, u plus half a, where t is 1. In which of the options, if I put t as 1, I will get u plus half a. It is only in option D I get u plus half a. Hence, that is the right answer. These are the unconventional ways to do a question very quickly. All I do is I put t itself as 1. So last 1 second becomes that is equal to u to the half a square, that t, as that t itself will become last 1 second. So if I put t as 1, I should get u plus half a. That only happens in t. Question number 3. Question number 3, wherever there are train overtaking questions, a train and bridge or train and other train, two objects in motion, always relative velocity, and time taken by the first train to pass the second train is always, okay, time taken is, add the lengths of the two trains. The length of the second train is 200. The length of the first train is 100. Add them both, you will get 300, and divide it by the relative speed. Both of them are moving in the same direction. So relative speed would be 40 minus 30, which is 10. And hence you'll get the answer as around 30 seconds. Shortest possible thing. Right? You so add the lengths of the two trains, divide it by the difference of the two speeds, which I take it as 40 minus 30, which is 10. The answer is 30 seconds. Then question number 4, an open lift and there is relative already. So what I would do is I would see everything in the frame of uh, the lift. I will stand inside the lift and see the object. How is the object projected? Object is projected with 20 meter per second relative to ground. And I myself, at that instant of time, I myself am moving up at 12. So how would I see this object, right? Well, I am moving up at 12, so I would see this object have a downward component of 12 also. Okay. So when I see the object with respect to ground, it has already 20, but due to me seeing it, it has 12 in the opposite direction. So according to my perspective, the object will have an upward velocity of 8 meter per second. Not only that, I am accelerating upwards with 3. So if in my perspective I watch this, this object will have a downward acceleration of 3 and nature, gravity already is pulling it down with 10. So total acceleration it will have would be 10 plus 3 around 13 meter per second square. So if I want a very fresh perspective, I will see the following. I am stationary. I am seeing the object move up with 8, u equal to 8 meter per second. And what is g value effective? G value effective is 13 because 10 is already by nature, 3 is due to my motion. So effective value of g is 13. Well, with u equal to 8, g equal to 13, it goes up, stops, and comes back. Now they're asking what is the time at which the object again meets the lift. I just need to find the time taken by this object to go up and come back to me. That is nothing but t equal to 2u by g. I will put u as 8 and g as 13. It would be 16 by 13. 16 by 13 is approximately 1.23 seconds. This is how simple relative velocity makes life. It makes life very easy. I am inside the lift and I'm watching the stone. The stone has an initial velocity of 8 meter per second upward and an acceleration of 30 meter per second squared downward. And then I use this very famous formula T equal to 2u by g, time taken for the stone to go up and come back, where u is 8 and g is 13. I get around 1.23 seconds. That is question number 4. Question number 5, it travels a distance x1 in the first half of time and x2 in the next half of time. How to relate both of this? This has been elaborately discussed in other videos too. We shall anyway do this. It would be the right approach would be to use our VT graph, and then right? It starts from rest. In the first half of time, it goes x1. In the next half of time, it goes x2. So this is, let us say, t. This is also t. Right? Half time, no? T and t. I need to relate x1 is to x2. Okay. So here is where I bring up a relative velocity concept. I need to, this is x2, the area under the curve, and this is x1. I need to compare this trapezoid area and this triangle area. So what I do is, I will first see the big triangle area and the small triangle area. This, I'll just compare how they are. Well, at the outset, the red triangle and the green triangle, both of them have are very similar. So there is a very famous theorem in class 10th, ratio of area of two similar triangles. That would mean area of the red triangle by area of the green triangle. right? The ratios of area of these is equal to the square of their corresponding sides. Now, what is the side for the red triangle? The side for the red triangle is 2t, t plus t, 2t. 2t the whole square would be 4t square. And what is the side of the green triangle? Just t. So t square is t. So I have area of the red triangle is 4 times area of the green triangle. What is area of red triangle? Area of red triangle is nothing but x1. X1 is 4 times area of the green triangle. How do I get x2? How do I get area of the red triangle is not x1. Sorry, area of red triangle is area of the green triangle, which is x1 plus x2, right? 4 times x1. So what is x2? X2 then becomes 3 times x1. How? Area of the red triangle is area of the green triangle plus this shaded area, which is x2. So x1 plus x2 becomes area of the red triangle. And what is area of the green triangle? Area of the green triangle is x1 itself. So x1 plus x2 is 4x1. So x2 becomes 3 times x1. With similarity, you can approach this very nicely. X2 becomes 3x1. So hence fifth one goes with A. Next, a body falls freely for 10 seconds. And what is its average velocity during this journey? They have just given the time for which a body falls freely. How will I find its average velocity? Average velocity for any object in free fall is u plus v by 2, right? And uh, well, it falls freely. So let us say u is 0, v is u plus a t. A is nothing but g into t. T is 10. So it would be 2 goes with 10 as 5, 5 into g, which is 50. Right? U plus v by 2 is average velocity. V is u plus at again. U is anyway 0, a into t. So that way it would be 50. Or else if you go by the technical thing also, s is equal to ut plus half at square divided by t, then also you will get the same thing. But I would always prefer for an object in constant acceleration, average velocity is u plus v by 2. Right. Now, question number 7. The person swims in a river directly opposite point. Well, so that would mean the river velocity is this, person's velocity is this angle is 120, so this angle is 60. If he has to go literally straight, then his horizontal component this way, that towards left, should exactly balance the river velocity. In other words, river velocity should be UP cos of that angle. Cos of that angle is by 2, right? It means river speed should be half of the person's speed. Person's speed is 0.5 meter per second. Therefore, river speed should be 0.25 meter per second. How? Well, the logic is he's going at 120 degree. So his this smaller angle is 60. His horizontal component is towards left. That should balance and cancel off the river component so that he gets to move exactly vertically. So it is half of his speed, around 0.25. Next question. A projectile when projected either with an angle theta or 2 theta has the same range r. Well, if a projectile has the same range r, then the sum of the angles of projection should be 90 degree. Complementary angles give the same range. So if I add theta and 2 theta, I should get 90. In other words, 3 theta is 90. So theta should be 30 degrees. The concept being for only complementary angles, range is same. So sum of theta and 2 theta should be equal to the uh, right angle, right? So that would be 30 degree. Question number 9. A projectile is fired with an initial velocity u. So, what is the potential energy at the maximum height? A little bit 10th standard concept over here. Potential energy is mgh. Mg h max is u square sine square theta upon 2g formula. So you cancel this off, half mu square sine square theta. This should be the right answer. All we just did was substitute h max formula in the mgh relations. Now going to question number 10. X coordinate is given, Y coordinate is given. I want you to find the initial speed of the projectile. I will compare each of the equation with S is equal to ut plus half at square. So the coefficient of t is always the initial speed. So ux, initial component of x is around 20, and uy, initial component of y is around 15. With vectors, it is one arrow is 20, the vertical arrow is 15. How can you find the resultant, the overall vector? Square root of 20 square plus 15 square, which is square root of 625, around 25 meter per second. So 10th one goes with B. Now 11th question. A projectile is given initial velocity this much. Find the equation of its path. Trajectory. For trajectory equation, if you notice, y is equal to x tan theta minus half gx squared upon u squared times 1 plus tan square theta. For this, I just need the theta value and u value, or tan theta value and u value, and I'm done. For that itself, they have given this information I plus 2j. All I need to do is represent it vectorially. I cap ka uh, uh, component is I cap means just 1 in horizontal, 2j cap means 2 over here. So the resultant speed of or u is square root of 2 square plus 1 square, which is 5. So I get to know that u is root 5. Not only that, I can find the tan theta also. What is tan theta? Tan theta is opposite by adjacent. So tan theta should be 2 by 1, which is 2. I know the value of u. I know the value of tan theta. I put it there and I get the trajectory equation. So they have given the initial velocity vector. From that, I need to extract both its magnitude, just as we did by plotting them horizontally, vertically, as well as I need to figure out the direction theta in terms of tan theta, of course. So this is 11th question. Now, question number 12. A car is moving at a speed of so and so on a radius 300 meters, increases speed at a rate of 1 meter per second square. Whenever you see something moving in a circle and it is increasing its speed, then it is non-uniform circular motion. It is not uniform circular motion, okay, because its speed is changing. So in this case, how do you find the acceleration? Well, for an object in a non-uniform circular motion, there are two accelerations. One, the tangential acceleration, one, the centripetal acceleration. Total acceleration of the particle hence is a vector sum of tangential and centripetal. So how do you find the magnitude of the two vectors, resultant of two vectors? It would be like Pythagoras theorem, right? AT is like this, let us say, and centripetal acceleration is downwards. So how do I find this length? That would be square root of tangential component square plus centripetal component square. Tangential component is already given as 1. Centripetal component A, that formula we know is V square by R. V is 20, 20 square is 400, 400 by 300, or it is 4 by 3. So acceleration centripetal is 4 by 3, tangential is 1. So the total acceleration is 4 by 3 square plus 1 square. If I do this, I would get the right answer. It should be 5 by 3 meter per second square. You can check it, right? So acceleration is 5 by 3 meter per second square. And how is it? The key thing to note is it is a vector sum of tangential centripetal. Centripetal formula is v square by r. Tangential component is what helps you to change your speed, increase or decrease. That is 1 meter per second square. Acceleration is a vector quantity. So I add them both. I get the resultant acceleration, right? That will be 5 by 3. Now, next one. Two particles of equal mass describe circular paths of so and so with the same period. What is the ratio of centripetal force experienced by them? Centripetal force, okay, this is about 13. Centripetal force, F, is given as m v squared by r, or in terms of angular speed, m omega square by r. I will go with v square by r for this. F equal to mv square by r. So they're asking what is F1 by F2. That would be mv1 square by r1 into you know, R2 by mv2 square. Just taking the ratios, m's and m's would get cancelled, and we just have um, v1 square by v2 square into r2 by r1. Well, it would appear that we are stuck, okay? Because there are a lot of unknowns, R2, R1, V1, V2. Now, how to eliminate these quantities? I can put V as R omega, where omega is the angular speed of both of them. Since both of them have the same time period, it means that they cover 360 degrees in the same time. In other words, both of them have the same omega. Since it have the same time period, it means it covers 360 degrees in the same period. So its angular speed is same for both of them. I put V equal to R omega here. So V1 equal to R1 omega and V2 equal to R2 omega, and then into R2 by R1, omega square gone. So I have R1 goes with R1 over here, R2 goes with R2 over there, and it is R1 by R2. So the ratio of centripetal forces is R1 by R2. Um, there is no way to guess this relation prior. There's no way to eliminate the options because all of them have R1, R2, and stuff. Well, both of them have the same period, so both of them have the same angular speed. So with that logic, we can go ahead. Or if you want the shortcut, shortcut is very easy. Within a jiffy, you can do this. You can express the centripetal acceleration as instead of v square by r, I can express this at omega square r, where omega is its spinning speed. Now, since both of them have equal mass, the ratio of the force depends only on ratio of the accelerations because F equal to ma, and if I take the ratios, right, m's could cancel anyway. It would turn out to be ratios of a1 and a2. A1 depends on omega square r1, and a2 depends on omega square r2. Omega squares cancel, it becomes r1 by r2. Because since both of them have same speed, since both of them have the same period, that would mean both of them have the same angular speed. So I cancel it off, I get r1 by r2, or R2 by R1. For this, it might be the second to the first. So that would be R2 by R1. Next, the ratio of angular speed again. How to find angular speed? Angular speed is the 2 pi by t. How much time does it take to cover 360 degrees or 2 pi radians? That is angular speed. Now they're asking second hand to the other hand. So angular speed can be written as the 14th one, omega is 2 pi by t. So omega for the second hand is 2 pi by, how much time does second hand take to cover 360 degrees? It takes uh, second hand, isn't it? So it takes 60 seconds to cover uh, uh, the 360 degrees. How much would a minute hand take to cover 360 degrees or 2 pi radians? It takes 60 minutes. 60 minutes is nothing but 3600 seconds. Now I divide both of them. 2 pi's gets cancelled and you have around 60 h to 1 as the answer. Omega is 2 pi by t. T for a second hand is 60 seconds, and the T for a minute hand is 60 minutes. 60 minutes is uh, uh, 60 into 60, 3600 seconds. So the answer should be 60 is to 1. The last question is the easiest of them all in the paper. You don't need to know any formula for this. They're telling uniform circular motion. Therefore, velocity and acceleration should always be perpendicular to each other 90 degree. That is how uniform motion is defined. For any object in uniform circular motion, UCM, acceleration will always be purely centripetal. Velocity will, anyway, it is always tangential. The angle between them is always 90, and hence 15th one goes with C. Well, these were the few very unconventional approaches and time-saving formulae for the kinematics question in your CET test 3. So keep doing physics, have fun with physics, and till next time, take care and bye-bye. All the very best for your future exam.